I do promise we will be doing a bit on our calculators as well, but that's separate and not today. You all should have received an email yesterday from me about in the event of inclement weather. And reading the weekend forecast, I don't know if we're getting 2 inches or 3,000 inches of snow this weekend, but if campus is physically closed, I'll take this stuff home and I will do the same lecture. You'll see the same thing on the camera, hear me in the background at exactly class time. I'll send out a Zoom link because that's how I'm recording this right now. You are welcome to join at that time or to watch the video subsequently. But I'm going to go on as if we have class, as long as I have power. So you might get another email from me Sunday night, Monday morning, but Duquesne Light says I should have. So we'll see. Meanwhile, I want to talk about the data we're going to use to do our statistical analysis. Data sources are all over the place. So you can get data from hundreds of thousands of places. There are ways to scrape entire websites to gather tables and statistics and other pieces they already have. And then you can pull that down and use it. You can also gather data yourself through surveys, through email polls, through all sorts of other instruments. I collect a bunch of data. An observation is one member of that collection of data. So if I think about student records here at Seton Hill, each of you is an observation. Each record for an individual. But that record contains a lot of information, and all of those characteristics are the variables for that observation. So I might be able to say home zip code, home telephone number, cell phone number, email address. All of those things are variables for each of our observations. A data set is the whole pile. Interestingly enough, data itself as a word is plural, but most people have stopped thinking of data as plural versus singular. You'll often hear people talk about the data and not mean a collection, but a single thing. Bugs the snot out of me, but I'm not a language police person. Take a look on page 23. I've got a table of data. Now, this data has 8 observations, and each observation has 5 distinct variables right up there at the top. Name, age, salary, position, veteran status, education. If I think of those as 6, I'm going to think of name as an identifier. And then we can think of it as 5 variables. If we think of name as one of the variables, then this is not correct, it's 6. But it is still multiple variables per observation, multivariate data. If we only have one variable we are concerned with, we could isolate that one and then have univariate data. We're going to start almost all of our statistical analysis on univariate data. At most, at the beginning here, we'll work with 2 variables. In quantitative methods, you'll work with much larger data sets with many more variables. So I get a pile of observations. I get the variables within those observations. And now I have to figure out what I've actually got. So really, I want to categorize the way I think of the data. And so now we can talk about the types of data. And I can think of qualitative data, categorical data. Your position title, off of that list of observations we were just looking at, is something I can't number. I might be able to take certain labels and put numbers to them, but then it would just be coding them as numbers. It wouldn't really mean anything. If I have the list of officers in a Seton Hill University club, I have president, vice president, treasurer, secretary, and SHGA rep. Does the order in which I write those things down matter? So if I label them 1 through 5 in the order I just gave, that's completely arbitrary. There really isn't a quantity idea here. Qualitative data is almost always words instead of numbers. The musical genre of a song. I heard somebody talking about music when I came in, talking about a song. Great. Is it a rock song, a pop song, an opera song, a country western song? I can think of the genre it falls into. I can think of the artist. What color is a car? Marital status, right? Single, married, divorced, whatever the categories of lists are, widowed. I think those are the 4 categories on the federal tax forms. But I don't put numbers to those. I can code them. I could say single, married, divorced, widowed as 1, 2, 3, and 4. But that's an arbitrary labeling. Even if I put in numbers, it's still qualitative data. For example, if I ask a yes/no question, I could write down your answers as yes or no, yeah? Yes.
Or it could be like maybe no could be 0 and yes could be 1.
Aha. Was there any requirement that I make no a 0? I could just as easily make no a 1, couldn't I? There's no difference in my coding, in my computer, in my spreadsheet, as long as somewhere I have a labeling system that says, oh, by the way, 0 is no, or 0 is yes. As long as I keep it straight. And as long as when I'm talking to other people, they know which way I've labeled the data. And if they labeled it differently, we can convert. Cleaning data sets, talked about that in DT100, is reconciling those sorts of differences. A yes, no, 0, 1 like this is called a binary variable. Big deal. And then I can now do things with these. But if I tell you, I took a survey of 300 people, asked them, do they like the food in the cafeteria, yes or no? The average was 0.27. Is that meaningful?
It's not meaningful at all.
It's useless information. Putting numbers on those pieces of information isn't going to tell me squat. It's still a yes or a no. And then I say, well, maybe more in one category than the other. So what I can do with the data is limited by the data type. Okay, the other side of this coin then is numbers, numerical data. Now, quantitative data is now an actual number. Age, salary are both in that example on page 23. Those are actual numbers. There are two subtypes here. Discrete and continuous. Discrete data counts a distinct number of things. The number of people that walked in the door to admin today. The number of people who rode the shuttle up from Elot between 9 a.m. and 5 p.m. I can only get integer values, right? They're distinct, separate categories. On the other hand, a continuous idea is a range. And I would go looking at all possible values. I want to measure the distance that each of us throws something. I can measure as accurately as I want, right? I want to use centimeters, millimeters, micrometers. How far do you want to go? It's up to you. But continuous literally means it can take on any value within that range to any level of precision we want. Leo, question.
So it's like you can have like decimals if you want to. You can have like accuracy even more.
Absolutely. I can give you as accurate as I want to be, as precise as I want to be. I could round. I could say, okay, instead of only measuring to the millimeter, I'm going to measure to the nearest meter, or I'm going to measure to the nearest foot, or the nearest inch. Height. Your identification contains your height. Depending on where you got your ID, it's either in feet, inches, or in centimeters. You rarely get somebody's ID that says they are 1.843 meters tall. They don't measure in millimeters. So, the way we treat our data, again, depends on its type. So, if I have discrete data, I really am probably not going to get more levels of precision further down the decimal chain than would be useful. If I've got numbers 1, 2, 3, 4 telling you it's 2.8375, not helpful. Continuous data, on the other hand, will get a lot more precision out of that. Questions? Yes, sir.
Could you please tell us another example of discrete data?
Sure. I can think of the number of people that earn each letter grade in a class. So I have A minus, B plus, B minus. I have all those grade options. How many people are in each category? To me, that the discrete idea is counting. I'm picking individual items out. Other questions? This is only one of my two ways of thinking of data types. I can also think of the data as to how it came to me. Time series data. Each observation is a distinct point in time of the same thing. For example, gross domestic product. The total amount of stuff made by the United States is measured at different points in time. The consumer price index, the unemployment rate, the 10-year treasury note rate, the Dow Jones Industrial Average, they give me that every hour. If I watch the market report, they'll give it to me just about every minute. You can get on the Dow Jones website, watch it go by as it updates throughout the day. But those are all time series. We see things going across. I can look at you and say, what's your attendance record for this course? What was your attendance record for the DT 100? What was your attendance record for whatever course I pick last semester? And that's you at different points in time, isn't it? So time series data measures usually an individual in time. I'm usually looking for trends, patterns. Is something seasonal? Does it rise and fall across the time of the year? Is something periodic? It rises and falls at the same points in time over the course of however long I'm looking at it. Or is there a specific kind of pattern? Cross-sectional data switches that. One point in time. Lots of different units. So I could ask, we took an exam. What were the grades? That's all of you as individuals at one moment in time. How long has it been since you, I'll pick something weird, last went to the bathroom? In minutes. Right now, look at you, tell me, I don't want to know. I don't want to know. But each of you is an individual observation at one point in time. Traffic accidents by state for a particular day, month, year, point in time. Tell me what happened. GPAs, company salaries. Lots of things we look for here are, okay, what's the variation? What's the spread? What are the relationships between different variables in our observation across this population? So time series and cross-sectional data are, again, another way to categorize this. Some pieces of data fit both categories. I did say the unemployment rate, right? But I can look at the unemployment rate in a location, Pennsylvania unemployment rate over the past 6 months. Or I can look at unemployment rate by state right now. In one case, I'm treating it as time series. In the other case, I'm treating it as cross-section. Usually we call those things pooled variables, and how we tease out which piece we want is then a matter of collecting the data appropriately. If I want to know more about variation by geography with unemployment, I'll treat it cross-sectionally. If I want to know more about traffic accidents at a particular intersection, well, then I probably want to treat that as time series and look at that one intersection. But I could ask the question, what are the most dangerous intersections in Greensburg? If you drive around here, what's the intersection you're most likely to get into an accident at? I don't know what the answer to that is, but that would be treating it cross-sectionally, not time. Or I could use both. I could look at all of the intersections over the past 6 months. And then if I want to know the most dangerous, or I want to know the trends over 6 months, how do I want to look at that data? Questions? If I ask you, who's your car manufacturer? What type of data is that? Yeah.
That'd be like categorical, it's like a type, not the number.
And I don't know if there's a reasonable way to assign a number to a car manufacturing company, right? Should I do it in alphabetical order? Should I do it in order of when they were founded? That's much better, I think, as categorical data. How many credits are you taking this semester?
Numerical.
Okay, now let me ask you the subtype. Discrete or continuous? Why? Why is it discrete? Yeah, it's a finite number, right? I count on, I don't know how to take half a credit, do you? So it's not going to make sense to think of that as a continuous idea. Now, here's where it gets a little pain in the ass to me. If you look online, full-time status at this institution is defined as between 12 and 18.99 credits. They used 18.99 because as soon as you get to 19, they're going to charge you for overload. But they didn't want to say between 12 and 18 in case some of the oddball individual lessons, like in the music department, can be counted as parts of credits. I don't know how to take half a credit because I've never done that in a math course, but I have done it in music lessons. It is very rare. It is usually done by special dispensation with the dean. The miles shown on your car odometer.
Numerical, and that's a continuous.
And if I actually look at the car's odometer, they've rounded it, haven't they?
Yeah.
Because the odometer clicks by in either tenths or whole units, depending on what you have it set to. But it should be continuous. The brand of cell phone in your pocket or on your table or wherever you put your cell phone. Categorical. Let me ask about this idea. The exam scores for Dr. Mahadi's midterm in EC 101 last year. Is that time series or cross-section?
Cross-section.
One exam, lots of different people, right? Cross-section. But one student's homework scores for that course would be, because it would march that one student through the whole semester. If I think about a piece that I calculate from data, I want to categorize it based on the data type. So I were to ask about the average score for the state CPA exam for the past 10 years. Where does it fall? Average score by all people who took the state CPA exam for each of the last 10 years. Say again? Because it's each of the last 10 years. I'm looking across that. Perfect. Now, once I know what type of data I have to know how I measured that data. And this allows me to figure out what I can do with it. The type of data I create, oh, by the way, page 24, a chart breakdown, categorical versus numerical. How I measure my data tells me more stuff about what I can do. I'm going to write this list in increasing order of things I can do. So nominal data, wait a minute, nominal. What's that word mean? Unfortunately, no, it doesn't mean numbers. But I can see where you would get number from nomen.
It's just like a naming thing.
Names. Names means this should be categorical. Categorical data usually falls into nominal ideas. Okay. It is common to use, when I have a list of options, other to make sure I cover all my bases. But all sorts of non-numerical survey data shows up here. I had a list of positions, job titles, in that table on page 23. We were talking about type of cell phone in your pocket, the manufacturer of a car. I really can't do much except list stuff here, right? But what I can do is count them, and I can look at frequency. If I asked about the colors of the cars in the parking lot, go down to E-Lot and tell me what colors the cars are. We're going to be bored sitting there for a while because right now they're all kind of gray, snow-covered crap. But red, blue, I don't know, maybe there's somebody got the lime green Scion down there. Who knows? But I can then tell you, oh, there were 37 red cars. There were 102 gray cars. I can count and do frequencies there. If I code these as numbers, the numbers are basically meaningless. They don't help me in any fashion. But if I still think about categorical data, but those categories now have a rank to them. Then I have a different type of measurement. I have an ordered behavior. Credit ratings, bond ratings. You get AAA, AA, A, and so forth in ratings on bonds. Credit rating, not your credit score, but are you a low credit risk, a moderate credit risk, a high credit risk? Frequency of use. How often do you check your email? Once an hour, more than once an hour, once an hour, once every few hours, right? There's a ranking there. But there really isn't a meaningful difference between, more than once an hour, once every few hours. They really aren't precise here. I can do counting and frequency, but I can also now do ordered statistics. I can ask questions about how many people said this or more, this or less, because I have an ordering to these. Now, that idea of order is something you may have seen before in things like what's the most frequent category, but also what's the middle of my pile of data. If I asked for half of the people are here or lower, half of the people are here or higher, that idea of lower and higher only comes up when I have ranking to my score. Things like quartiles and deciles, percentiles show up in this idea. Those are typically quantitative, but they don't have to be. ranked. What if the ranks have specified gaps between them? A lot of times we ask about places like Seton Hill, we ask about pay scales. Well, if I divide those up by, say, $10,000 increments, who's making between 1 and 10,000, 10,001 and 20,000, 20,001 and 30,000, right? I can break these up now into categories that have distinct intervals between them. Rather than just a ranking, the difference between the values is now meaningful. Something like a numerical scale or a Likert scale will fall in here, yes.
Is it still categorical?
Well, that's the best part. Interval data can actually work both ways. We can do this for categorical data when we code it numerically. This also works really well with quantitative data. So if I think about a Likert scale, which is usually a survey where you get, give me a rank from 1 to 5 or 1 to 10 or something like that. I hate it. I don't like it. I don't care. I like it. I love it. That's going to fit a Likert scale. Well, then the difference between 1 and 2 is the same difference between 2 and 3. It's the same difference between 4 and 5. The differences in the category matter. But the rate, there's no 0 here, is there? The scale doesn't contain a meaningful idea of 0. By the way, that Likert scale idea, 1 through 5, I've made a deliberate choice there. I included an option exactly in the middle, a true neutral position. If 1 is I hate it, and 5 is it's the best thing on the face of the planet, 3 is eh. Well, what if I don't want that? What if I want to force my respondents to pick a side? Is this thing good or bad? Then instead of having an odd number of options, I should have an even number of options. If 1 is it sucks and 4 is it's the best thing on the planet, there isn't a spot for eh. You have to decide, is it better or worse, 2 or 3 in this scale? So deciding on an odd versus an even is a way to design your question to push answers. That's an important idea because as well as what kind of data do we get, how we get it can force the data in certain directions. The way we ask the questions matters. Again, I can code these. I could say, oh, 1 is horrible and 5 is great, or I could reverse that and say 5 is horrible and 1 is great. I've been here a long time, people. 20-ish years ago, I had a student in a statistics class do a survey of, do you think the president is doing a good job? 1 is no, 5 is yes. Fill in the blanks in the middle. President sucks, the president is great, here. He did the same survey the next day. 5 is sucks, 1 is great. He did the same survey the next day. Instead of going from 1 to 5, he went from 1 to 10. And the next day, he reversed it. Instead of 1 being horrible, 10 was being horrible. You know the fun part? When he ran the numbers, it didn't matter which survey he gave, they all came out with the same average. People didn't read the instructions. Be careful when you design the question. If I want 1 to be great and 5 to be horrible, and people don't notice, they're going to say this guy sucks a lot more than they're going to say, oh, I like what he's doing. Brian Harmon works for Management Services Associates in Pittsburgh in data analysis. It is assumed that Likert scales and interval data have unbiased calculations, which means I can now look at more calculations. I cannot just do counting and frequency and order. I can also do averages, variability, which can be measured through variance or standard deviation. I can do lots of additional calculations. I can also kind of make it look like my Likert scale is actually continuous. I am signed up for my electric company through Duquesne Light. And every now and then I get a survey from Duquesne Light, and there's a slider on there. And they ask me to position the slider as a response to a question. But if you're not paying attention, you don't notice that the slider actually jumps. It doesn't slide. It isn't really a continuous idea. It's a discrete one, but it's been masked. Bottom of page 29, we see those sorts of sliders in questions. The thing I can do the most analysis with is ratio data. Almost always, we're referring to quantitative data here, not qualitative data. Because the only difference between interval and ratio is 0. And the reason I think about this as ratio data is I'm literally thinking about the multiplication. 20 pounds is twice as heavy as 10 pounds. $40 an hour is twice as much as $20 an hour. 150 kilograms is 3 times 50 kilograms. Interestingly enough, temperature is not ratio data. For Celsius, centigrade, or Fahrenheit, there is one temperature scale that is ratio data. Who's been in a chemistry lab? What's the data degrees they use in chem labs?
We get Kelvin.
Because then 0 is the absolute cessation of all heat. There is no motion of any molecule. Kelvin is the only temperature scale that is commonly used that is ratio. Celsius and Fahrenheit, where is 0 Fahrenheit? I know what 0 Celsius is. What's 0 Celsius?
That's 32.
That's conversion. It's the freezing point of water. 0 Fahrenheit? Do you know where 0 Fahrenheit came from? Fahrenheit mixed salt and water to get stuff as cold as he could get it. And he called that 0 Fahrenheit. He made it up. By the way, if you convert Kelvin to the Fahrenheit scale, you get something called Rankine. Again, named after the guy who did it first. Nobody uses that damn thing anymore, but there is another version. Rarely will you hear somebody talk about twice the temperature. The fact that it's 80 degrees doesn't mean it's twice as hot as 40 degrees. So it's not a ratio idea because the zero in that game isn't meaningful. I can do the most here. I can do all of these calculations, but then I can actually relate that to the meaning of zero. And that makes this, I think, the most useful type of data to have when you're doing numerical calculations. Questions? Page 27, bottom of the page. Is there an ordering to my data? If the answer is no, then I've got nominal data. If you can't figure out the order in which those labels go, that's nominal. If there is a naturally occurring order there, then I'm at least ordered. But if the differences in scale have meaning, then I'm going to go up further. If there's zero that has meaning, I go up further. Nominal, ordinal, interval, ratio. And it even tells me what I can do in terms of the types of calculations. This illustration is page 27. If we think of this as an increased list, least things I can do to most things I can do, it's possible to recode down. If I have ratio data, I could treat it like interval data. If I have interval data, I could treat it like ordinal. I can't go up. I can only go down this list. If I think about blood pressure. Blood pressure is ratio data. If you have a zero blood pressure, you are dead. I hope that never happens. I know it will eventually, but I don't want to anytime soon. But I don't want to treat that as ratio data most of the time. I want to treat it as ordinal data. You have low blood pressure, high blood pressure, or an acceptable blood pressure. Because there are medications for these, but if you've got normal blood pressure, I don't have to worry about it, right? So not caring exactly what the numbers are. Is it low, normal, or high? That's just ordered. We can put numbers in there. And the intervals will have meaning. So I could take my ratio data and treat it as interval, or I could take my ratio data and treat it lower as ordinal. Questions? I go down to the lacrosse field, grab a player, and I say, what position do you play? What measurement level is that?
Got the agnometer.
Because I just got a name, right? What position? Is there a ranking of positions? I don't think so. There might be a ranking by number on the jersey. I don't know if all positions have the same kind of numbers. No idea. If I pick a professional baseball player and I look up their salary, what type of data am I getting?
Would be none.
Say again?
Would be none.
Why ordered? I'm looking for their salary. I'm in the numerical already, so I'm probably looking a little higher than just ordinal. Salary of a professional baseball player.
Interval.
Do we have rankings? Well, I have low to high, right? Is there a zero that means something in that measurement? Yeah, you could be getting paid nothing, right? And that would suck. So I've gotten all the way to interval and I have a meaningful zero. That's actually ratio data. Which means I can compare salaries Shohei Ohtani is making $21 million this year. That is 5 times so-and-so's player, or 10 times so-and-so's player, or whatever, right? So I can do those sorts of comparisons because the zero is meaningful there. More questions? Okay. So I have measurements, and I get my measurements. I have what kind of data I got. I have what level of measurement that data tells me. And now, how do I get it? Need a couple other terms. If I am asking about baseball players, I probably should be a little more specific. I said professional baseball players. Should probably be even more specific. American, players of American baseball. That's the whole group, right? That's everybody. That's the population. But I might not have access to the entire population. In which case, if that's a very large group, it might be difficult for me to get data from all of them. Maybe baseball players is too small of a group for me to think of as a population. But if I asked about all of the people in the state of Pennsylvania, I might have trouble getting them all to answer a question. So instead, I will take a sample. This ideally is a size of group we can handle doing the analysis on. So while there are 12 million people in the state of Pennsylvania, I might not want to do a data set of 12 million items. Crash my computer really quickly. But if I ask 3,000 or 4,000 people a survey question, I might be able to get a good analysis. If I ask everyone in the group, then I'm not doing a sample, I'm doing a census. This is not often easy to do. We hear the word census, and we usually think of the every 10-year census done by the federal government to do apportionment for the houses of Congress and state legislatures and things like that. We do that, well, we did that in 2020. We're still doing the analysis from the data. That's why you only do it every 10 years, because you got to ask about all 330 or 350 million people in the United States of America. You're going to be here a while. But there are other cases where I might not want to do a census. I'm going to test bumpers on cars for how well they withstand impact. That's a crash test. Do I have the bumper to look at after I'm done? If I did a census, I wouldn't have any bumpers on any cars. I would have tested them all and they would have broken. It's not a good idea. I might prefer a sample if I can get faster results, if it's going to be useful, it's going to lower my costs, it's going to be accurate, or if I'm going to use sensitive information. If I have an existing database, if I wanted to know something about all the students at Seton Hill, I could probably go over to the registrar's office and ask. Whether or not I'm allowed to know is a whole other story. But if a database already exists, it might be fairly easy for me to do a census. So there are cases where one might be preferable over the other. I want to talk about what we do with our census, with our sampling, and how we get that sample. But that is going to wait until Monday. Hope to see you here. But if not, you'll get an email from me, if I've got power at home, telling you here's a Zoom link. And if you don't watch it live, please watch it before Wednesday. Yes, sir.
What's the main difference from population and data set?
From population and data set, well, the data set is what I get out of my process, right? The population are the things I'm interested in. If I did a sample, I still have a data set.
Okay.
The data set is the results of the pile I'm gonna work with. Hang on a second.
Alright,